Welcome, welcome to everyone who's joined to our last Dorse Power Hour, going over energy recovery. Welcome our Seattle sales engineer, Chris Woldridge, who has set up most of these power hours, and I'm sure he'll chime in at the end. But thank you to him for setting these up. And then we have Jordan Locker, who will be presenting on energy recovery, the latest and greatest, and Greenheck technology. We'll go over energy recovery ventilators and maximizing that high performance DOAS, and we'll highlight the new ERVI and IVE models that Greenheck just came out with. Really exciting stuff here. Couple housekeeping rules. Everyone's on mute, so if you have a question, enter into the chat, and we'll make sure to take care of that as it comes about. And I will hand it over to Jordan Locker, who's been in industry for quite some time. He's an ERV expert, and he's got a great presentation on the latest and greatest. Jordan, I'll let you introduce yourself and get us kicked off.
Awesome. Thanks, Blake. So like Blake mentioned, my name is Jordan Locker, one of our application engineers here at Greenheck. I've been focusing on energy recovery for a few years and excited to talk to you folks and kind of explain, what Greenheck has to offer, what the technology is all about. And, specifically, Washington State, you guys are one of the most progressive code states in the country related to energy recovery. So, really interested to hear what you guys have to say and any questions, and then we can talk all about it. Okay, so at the absolute basics, right, for anybody who has not seen it, if I can get this guy to run. Maybe not. So hopefully we all know what an ERV looks like, right? It's pretty basic. So on the right-hand side here, you have your hot and humid outside air. It's going to come through the wheel. The wheel is going to exchange heat or moisture across that exchanger and returning that relatively cool and dry air during the summer months. So during the summer, the name of the game is preventing that high temperature, high moisture air from getting into the space. In the winter time, right, this is exactly opposite. So now the outside air is relatively cold and dry. The return air is warmer and more moist, relatively speaking. And we're going to transfer that heat and moisture and keep it within the space and prevent that cold, dry air from coming into the building, right? So that can either be done with a wheel or a core. So big thing, focus is, one of the big differences we see is enthalpy recovery versus sensible recovery. So for Greenheck, our focus is on enthalpy recovery. The metric that we're using here is ERR, or enthalpy recovery ratio, right? One of the bigger changes to the Washington Code, right, is they did adopt an enthalpy recovery minimum. So that minimum is 60% ERR. Right, you can see that equation for ERR. It's just the change in enthalpy of the supply air over the change in enthalpy of the return air, right? Big thing with enthalpy recovery, right? So the easiest way to spot this, ERVs, right? They do not have condensate drains, right? So we are transferring the moisture from one airstream to the other. We're not condensing it out of the air. Across North America, enthalpy recovery is a really great technology and provides a lot of benefits. The flip side to that, you can also focus on sensible energy recovery, right? So this is where things get slightly confusing. So I put the term sensible energy recovery ratio, or SERR. That's one of the terms that the code regulator folks have been using. Washington State also decided to call this sensible recovery effectiveness, or SRE. I will admit that that's a little confusing because that term is also used in the residential ERV market. So, don't worry about getting too confused there. Basically, you can see the equation. It's the exact same equation as ERR, just instead of looking at enthalpy, right now we are looking at temperatures. So the change in temperature of our supply air over the change in temperature of our return air. And Washington State does have a higher minimum recovery if you're going to focus on sensible recovery, right? So that's 68% versus that 60%. So one of the big things I'll say about sensible versus enthalpy, right? Across the board, obviously, that Pacific Northwest climate is a lot milder and drier. However, with that being said, right, there is still great benefit to using enthalpy recovery. Um, for us as a manufacturer at Greenheck, we see a lot of benefit in just building enthalpy recovery for all of North America. And really, there's few and far between situations where you need to have sensible only, right? So there's a lot of misconceptions out there that, for some reason I can't use ERR or ERV, right? It's not really true. The big thing too is, these are still exhaust fans. You're still going to be exhausting moisture from the space. It's just not as big of a concern in a milder climate. So for Greenheck, we promote using ERR enthalpy recovery. However, that sensible recovery metric can be used as well. So two technologies, right? You got wheels and cores. The most common types of wheels that you'll see in the industry are aluminum wheels and polymer wheels. For Greenheck, we exclusively deal with polymer wheels on our standalone energy recovery. Big difference between the two, they're both very, very effective, right? So wheels are the most effective technology out there. However, there's a difference in the thickness of the media to accomplish that, right? So generally speaking, aluminum wheels are much thicker than polymer. So you can see that 4 to 12-inch range, whereas our polymer wheels come in a standard 1.5 to 3-inch size. From an enthalpy recovery point of view, 70 to 80% can be expected. And then also there's a difference in the technology of the desiccant, right? So for an enthalpy wheel, we need to apply a desiccant to that wheel to recover the energy. Aluminum wheels use what's called a molecular sieve technology, and polymer wheels use a silica gel desiccant. Right, so what that looks like, that silica gel desiccant, it is a permanently applied chemical coating, right? So these are lifelong wheels. They're designed to be washed, cleaned, reused, right? We don't want to throw them away. Really the only reason you'd be throwing away a polymer energy wheel is, misuse and damage to the wheel. The other big difference is the construction of the wheel, right? So those aluminum wheels are typically a single piece wheel. It's like an aluminum ribbon wound onto a core. So they can get quite large, quite bulky, and quite delicate to deal with. Whereas those polymer wheels, we use these removable segment pie piece shapes that those can be popped out. They're very easy to handle, very easy to clean, and durable in the sense of getting dinged and damaged. So both wheels are washable, right? So you can see there water and soap detergent. The only big difference being typically they'll use a pressure washer and more high pressure on that deeper aluminum wheel. You don't want to do that on a polymer wheel. You can potentially cut right through it. So it is a low pressure water wash. On the core side of the market, right? So there's two primary core media types that are out there. A fiber core is a paper-like material, and then a polymer core, very similar to that wheel, it is a plastic type media, right? That is a washable and reusable core, right? So you can see the difference there. Cleaning, one is vacuum only, one is low pressure water wash. The big difference being with cores compared to wheels is lower performance, right? So 50 to maybe 65% ERR is what can be expected. So, as you can imagine there, those fiber cores, they're a little bit harder to hit those code minimums. So typically we like to use the polymer cores, and that's something that, slightly unique to Greenheck. A lot of the other competitors in the market are only using a fiber type core media. Comparing wheels to cores, right? So there are some differences in the technology. If we talk high level, right, the big draw to a core is hey, it's simple, no moving parts or pieces, right? That's always kind of been the appeal to that. But with that being said, right, there are some significant drawbacks as well, right? So if we take a look at performance, you can see that wheels are going to win out on both sensible and latent performance. Sensibly, cores can do okay. Latent is really where the drastic difference is, right? So you can see that difference between 65 to 80% latent recovery on a wheel, closer to 30 to 50% latent recovery on a core. So if you are in a higher moisture environment, that wheel is going to provide significantly more recovery. The other big differences, so EATR, that stands for exhaust air transfer ratio, right? That is commonly called cross leakage, or how much leakage you can expect on the device. Wheels, it's common to expect around 3 to 5% leakage. So this is slightly higher than a core. Cores are typically 1% or less. However, I would say that code requirements state that you have to have less than 5% leakage to handle class 3 air, right? So if you're not familiar with what that is, class 2 air, that's like your bathroom exhaust, right? Typically to handle bathroom exhaust with an ERV or DOAS system, you have to be less than 10% leakage. And to handle class 3, so that's like a vet office or a nail salon, you have to be less than 5%, right? So that is one true advantage of a core. The other one that I'll point out there is pressure drop, right? So typically we see less pressure drop on a wheel. It's a thinner media than a core. These are kind of just sort of average ranges that you might expect here. Where that really comes into play, we'll talk about in a minute here, is fan power, right? So typically the fan power requirements on a core are significantly higher because we need more energy to push that air across that deeper media, right? So that's going to be a big advantage of a wheel. Last one I'll say is just kind of general sizing, right? So in the smaller airflow ranges, right, if you're under 1500 CFM, it's kind of more of a pick your flavor. When you get to higher CFM, you're pushing 2, 3, 5, 10,000 CFM. The advantages of the wheel, really start to become greater and greater, and the sizes of those cores start to grow significantly. So for Greenheck models, I'll kick things off by talking about our smaller units. So we like to call these like our light commercial units. So we have the mini core and mini vent, right? So obviously the mini core is using a core media, and the mini vent has a small wheel in it. We have 2 cabinets in each of them. So typically anywhere from 150 up to about 1,000 CFM. Right. These are very attractive units, right? If you need that, small footprint, really awesome price point, relatively simple, right? So just an indoor ERV, maybe a little bit lighter on the control side. These work really well in the market. Something that's very powerful is actually we use our very green EC motor technology. So all of these mini core and mini vents have independent fan control, right? So very, very powerful option there. I will mention too, so that mini core that's pictured on the right there, that unit can also be reoriented in any direction, so horizontal and vertical. And then they actually do have configurable ductwork as well. So it is field configurable. Basically, we kind of ship them as is from the factory, and then they have blank off plates. You can kind of see on this mini vent here, there's 2 different openings. One will have a cover plate on it, one will not, and you can change that ductwork accordingly. So very, very flexible unit. These are super popular, bathroom exhaust fans, right? It's a very easy way to get your energy credits by using energy recovery in a simple, flexible, and easy to use package. Moving on from the minis, right? So we also have our ECV. So this is our larger core ventilators. So 4 sizes of this, the 10, 20, 30, and 40. Basically, that's the number of cores that are in the unit, right? So we go from a 1 a 4-core unit. You can see the airflow ranges there. Typically max out about 5,000 CFM. Right, ECV gets into our full-on commercial line, right? So this is going to have, all the bells and whistles, controls, dampers, BMS, lots of different control sequences, sensors, kind of anything you can think of in that sense of truly making this, a full-on DOAS unit. It has a lot of that capability. On the wheel side of things, so we do have two different wheel models, both the ERV and ERVE, right? So these are, small to large wheel ventilators, so anywhere from 500 to 12,000 CFM, right? Same thing, indoor or outdoor mounted, and these are full-on commercial units. So, just about anything you can think of, other than tempering included in the unit, right? So these are standalone ERVs. They do have the ability to control downstream heating or cooling, but we don't have full-on tempering built into these models. Okay, so that kind of wraps up, call it the little bit more basic side of energy recovery. So hopefully get your feet wet. Hopefully we all are familiar with that. I did want to kind of shift gears here a little and focus, more specifically on that high performance DOAS side of it, right? So, why are we talking about, there's both high performance DOAS, very high efficiency DOAS, lots of different words out there. There's two real drivers of it. So one, I have a couple screenshots here from the NIA Better Bricks group is kind of an incentive agency pushing this technology. So really the reasons to use this technology, one, we want to increase ventilation in our spaces. So if we get more fresh air into our buildings, everyone's going to be happier and healthier. Two, the drive is to fully decouple that ventilation load, right? So by using very high efficiency equipment and decoupling that ventilation, typically that ventilation is one of the biggest energy hogs on the building. So by decoupling it and using high efficiency equipment, we can drive down that energy usage. Like I mentioned, high performance, that goes very hand in hand with electrification as well, right? So obviously on the West Coast, your guys' electrical costs are significantly less than ours here in the Midwest. So using that high efficiency equipment works very well when paired with fully electric systems. And then the last one is trying to drive that right sizing, right? So picking an appropriate size of ERV to maximize the benefits and get the most out of it. So I will just mention that some of our Greenheck models are listed on these high efficiency programs. The other big driver of it, right? So this section 406, 226 in the Washington State Energy Code, right? There is specifically a call out and energy credits for that high performance DOAS system, right? So this has been pushing towards some of these, newer technology, really trying to maximize that benefit of energy recovery. So we'll talk all about our new models here. I have that new ERVI pictured on the screen. And so some of the things we'll talk about related to this high performance code. So number one is how do we maximize our energy recovery? So really the three tricks to it. One, thickness of the wheel or the media. Number two is cabinet sizing. And then number three is making sure we're using balanced airflows. So to show you an example of that, right? So if I increased my wheel thickness, right? So if you look there in the top left, if I do a ERVE 20 with a 1.5 inch wheel, I'm probably sitting around 78% ERR. However, if I go down to that ERVE 20-30L that uses a 3-inch thick wheel, right, I can jump up to 81.5% ERR, right? So that's approximately a 6.5% bump in energy recovery just by going with a little bit thicker of a wheel. The other one is cabinet sizing, right? So, you can see here going from a nominal 2000 CFM cabinet, jumping up to a nominal 3500 CFM cabinet can get us some significant gains as well, almost another 5% there. So we have seen that trend across the market of basically using one size larger ERV, trying to move less air through it, right? Like any heat exchanger, the less feet per minute you have across that exchanger, typically the more efficient it is. So it is quite common to see those ERVs being oversized a little bit to try and maximize that recovery and benefit.
And Jordan, and mentioning this, like coming from the rep side, what we would ask the engineers to do, or whoever's specifying and scheduling the equipment, is to specify the effectiveness, because as you can see, there is an increase in that relative cost. So it's to not only specify the effectiveness, the increase in effectiveness over a smaller model, but also hold that spec. Because you might have chosen the larger unit because you wanted the effectiveness, but if another manufacturer is coming in, or another rep, another vendor, and they might just supply a code minimum equivalent, whereas we as Dorsey and Greenheck are trying to bid what you intended with the larger model, we would undoubtedly potentially lose out on a project for somebody bidding a smaller, less efficient, less effective, cheaper unit. So we always say schedule what you want, schedule the model number, schedule those effectiveness values as the absolute minimum. And then the most important thing we always say on the rep side of the business is hold your spec in that regard. So just wanted to throw that in there, Jordan. Thanks.
Yeah, great point from Chris. Yeah, so really, driving those higher numbers and trying to push usage of energy recovery is the name of the game. The other one here, I'll point out just balanced airflows, right? So, energy recovery works best at a balanced airflow. So these examples here, you can see, right? So going from, a heavily unbalanced, less exhaust than supply to a more balanced system can have significant gains in energy recovery as well, right? So I always like to preach that, even a little bit extra exhaust to that unit can make a big difference in the overall performance of it. And as you can see in this example, right, sometimes it can be the difference between whether or not you're meeting code just by getting a little extra CFM to that unit. So trying to maintain those balanced airflows as much as possible is a way to maximize the performance of these units. The other thing that we see, so code driven is really minimizing fan power, right? So the idea is, okay, we're using a very effective ERV. We're recovering as much energy as possible. At the same time, right, we don't want to forget about our fans. So we don't want to burn more energy than we need to, moving the air across that ERV, right? This is written into the Washington State Code, right? So I have that section there, basically requiring less than 1 watt per CFM. So I just threw an example up there on the top right. Most critical thing we see here is really, doing a good job with those external pressures, right? So, how much ductwork is there? What is this unit ventilating into? So we do see a lot of times where, maybe folks are just kind of guessing at those numbers. Being more exact is going to really help drive down that watt per CFM number and make sure we have an accurate assessment of that. The other thing too is, the less restriction on the unit, obviously the less fan power we're going to need. Okay, so those are ways to maximize the use of ERVs. So I wanted to kind of take a minute to step into our new products, right? So basically the idea was Greenheck said, hey, we're seeing a lot of this code high efficiency DOAS. Let's go after it. We're seeing a lot in the indoor side of the market. So we are working to develop a brand new product line specifically tailored to that indoor ventilator market, right? So the 2 new models that we've released, one is the ERVi that's on the left. So that is an indoor energy recovery ventilator. So that is energy recovery only. And then the model on the right, that is the IVE or indoor ventilator with energy recovery. Basically the difference being, ERV only, or do you want some additional post tempering, right? So depending on which part of the state you're working in, you may or may not need that. So really, why did we drive towards this? So, we're seeing as this technology picks up in the market, that retrofit modular need is growing. It's very high, right? So offering a low profile ceiling hung unit, typically going into some, crazy space that you can't get into, and how do I get the unit in the building? So we designed a unit that was completely modular and would fit through 30-inch service doors and elevators, right? So, to meet these high performance stretch codes and any of those indoor air quality improvement projects, this should be a really great offering, and something that, should be able to meet a lot of jobs that maybe we couldn't have before. Where we see this very popular, right? So schools, nursing homes, anything with a pitched roof building. So typically having that limited mechanical space, right? You can't get away with a large indoor unit that has a lot of headroom. Basements, attics, crawl spaces, right? Anywhere where we have a height constraint, this product line is going to be really great for that. We've seen it starting to move into some more high-rise buildings as well, right? So, sometimes it doesn't make sense to put all your equipment on the rooftop. Sometimes you can split it out floor by floor, right? So that's where this form factor works well. And then, like I mentioned, the more we get into electrification and air source heat pump, using energy recovery is honestly just a no-brainer. So starting off with that ERVI, right, we do have two different cabinet sizes. So this is the ERVI 10, goes about 375 to 1500 CFM, and that is an 18-inch tall cabinet, right? We also did an ERVI 20, and that goes all the way up to 2500 CFM, and then that cabinet is 23 inches tall. Right, so you can see there, there's a lot of technology really in a small package, right? So, there's a lot of controls, a lot of different things going on, EC motors, dampers. So to get all of that technology into as compact of a space as possible and still keep that modularity was, something pretty innovative. On the IVE side, right, so this is pretty much the same thing as that ERVI. However, we do have it available with electric post heat, right? So now we add an extra module there, right? That extra module adds the electric heater. And then you can see there, same cabinet sizes, just a little bit lower airflow on the higher one due to that pressure drop of that electric heater. Like I said, modular, right? So it gives us that ability. The cool thing is we do ship them from the factory fully assembled. It's super, super easy to break down. I have some pictures here I'll show you in a minute. The whole thing is built, as intuitively as possible. We have some pigtail connections there, very easy to break it down and get it into that space. And really the advantage here, we see a lot of times using an ERV, right? We might want to boost that supply temperature just a little bit higher. Might be a little bit cold and frigid coming off of that wheel. So adding an SCR controlled electric heater, some of the advantages of that, one, you can hit whatever LAT that you're looking for. And then two, this is all factory installed, factory tested and single point wired, right? So, if you compare that to just an ERV with a field installed duct heater, it's a very clean, very well designed package that reduces some of that hassle of installing it in the field. Some of the standard features we included on this new indoor series, right? So it is full factory controls, right? So we're always doing that microprocessor controller. We chose to do a Permatector painted exterior, right? We tend to find just a little bit nicer fit and finish with that. And then this is also a 1-inch injected foam construction, right? So a little bit more premium in that sense on the DOAS side of the market. And then across the board, direct drive plenum fans using EC motors, right? So we do have single phase and 3 phases available. in both cabinet sizes and both with the ERVI and IDE with electric heat. So whatever your voltage, whatever your project, there's a lot of great options here for that very high efficiency project. Some of the optional features, right? So we standardized on using a 3-inch thick wheel, right, to maximize that recovery. There is a difference in either a high effectiveness or high flow wheel, depending on the airflow that you're looking at. We can do up to MERV 13 filters. We have factory installed dampers, all the different BMS protocols. You can control downstream heating or cooling, right? So if you did want to pair this with some sort of split coil, and then we have built-in factory frost control and economizer sequences, right? So whether it's a preheater or being a wheel unit, that modulating wheel is a really awesome option there for both economizing and frost control. You can actually slow down the speed of the wheel and gain a lot of benefits that way. So very, very powerful. A lot of different factory sequences that are included with these units. The other big design point, so we try to make it as flexible as possible, right? So we do have flexible connections, so it's available in either end or side discharge. So you can see those two pictures here. Just gives you a little bit more flexibility of where you want to locate those ducts and how you want to get it into the building. And then we also saw a need for a right-handed or left-handed access. So I'll show you a picture here in a minute, but basically the entire back wall of that unit can be pushed up against a wall, and the entire unit can be serviced from one single side, right? All the filters, all the blowers, everything can come through that unit, and then offering, which side you'd like that access on. A mirrored configuration is also very powerful to get it onto that job. So I figured I'd add some pictures, right? Nothing's better, pictures worth 1,000 words. So here's some pictures of the ERVI 10. So this is that smaller cabinet. You can see here one of the really cool things about this design. So that top right picture, you can see we got that BB label. So we put AA, BB, CC, right? It's very, very simple and intuitive. The other nice thing is we went with this kind of unique door track style, right? So they are what we call captured access on the doors, right? So these doors slide on a door track. So if you're doing standard maintenance, you can just slide it to the side without having to hold the door. Or if need be, you can actually see here, you can tip that door out and take it completely off. Right, so that was one of the things we saw is, having these large swing hinged access doors can be quite troublesome, depending on the piping that's in the building. So trying to keep that access as small as possible and make it as accessible as possible. Next pictures here. So the two on the right show those modules split apart, right? So it does have these nice 12 gauge brackets on the exterior designed right from the factory for hanging or supporting from the base. And then you also have those male and female locating tabs, right? Makes it super, super simple to put these together. I'm talking a 5-minute job to split it apart and put it back together. You can see on the top left, that is the wheel that slides out. And then we have our control panel right there with all the controls on the unit. This is some pictures of the larger cabinet. So the ERVI 20, right? Same thing, comes in 3 modules. All of these units are fully unit tested before they leave the factory. So everything has been proven and tested. It is operational. And then you can actually see there on the right, that module has that electric preheater built right into it. So depending on what frost controls you might need. Then this is just a picture of the larger, so the IVE. So this unit has that post electric heater as well. So getting that SCR controlled electric heater can take out whatever final tempering you might need to supply directly to the space. Another note on this is actually the side discharge connection unit there. So just a little bit different. And then picture on the right, so you can see that is a rotation sensor on the wheel, right? Basically, cheap insurance just to say, hey, that wheel is rotating when we expect it to. And then just captured a picture of that filter access door, right? So change the filters on the backside, you actually pop open a trap door and pop the filters out from one side of the unit. So other than that, any questions or any thing we'd like to discuss?
Not seeing any questions, but we'll give people a couple minutes in case. Oh, we got one question just came in. What are the clearance requirements?
What was that? Can you repeat it?
What are
What
the
are the-
clearance requirements? It's like, well, I'm assuming this is referring to probably the ERVI and the IVE.
Clearance requirements?
Yeah.
Yep. So the smaller cabinet, off the top of my head, I want to say it's 34 inches. Which the nice part with that is if you think about, technically your NEC with your electrical access panel, right? That's about the same size as that. So that's what's required to fully slide the wheel out. And like I said, it's all on one side of the unit. And then the larger housing, I think it's 42.
But those are
Wait,
single side access, right?
Correct. Yeah.
So with
if I
that can
find-
save it. You don't have to worry about having that all the way around the unit. If it has to be up against another piece of equipment that doesn't have clearance on the side or a piece of structure, you just need that on one side.
Yes.
When are the IVE units available to ship? Thank you, Jake.
Yeah. So, like I said, the ERVI was launched in December. The IVE, we are able to make selections for you, right? So we can give you all the sizing and performance there. And those should be going live for production here in about a month and a half. So August.
Yeah, I think it was
August is those will be available.
about the first week of August. I'm counting down the days to that too. We have plenty of selections we've given engineers for projects and design, knowing by the time they get bids submitted, it'll probably be about that time period. So we're excited to get those on order. Do the mini vents come with necessary sensors controls to have a bypass economizer mode?
Yeah, so that is one difference. Kind of the small light commercial, those minis. So they are a little bit lighter in that sense. They don't have the economizing controls built right in them. So typically, if we wanted an economizer, that's where we would recommend the little bit larger, full-on commercial units.
On the
And
mini
I can
vents,
chime in. I
Go
can
ahead.
chime in there too. The mini vents don't have economizer, but I believe in the code for the high performance DOAS section 2, if it's greater than 500 CFM, it needs economizer. So if it's less than 500, it would not need an economizer, and that's where that mini vent 450 VG, would be perfect for those credits, because it doesn't need an economizer at that lower airflow. If you do need the economizer above 500 CFM, the ERV10 model has that economizer available.
Yeah, great point, Blake.
Let's see, when will caps be updated? Michael, are you referring to selecting the ERVI and the IVE? That should be in there already.
I don't think in our engineered desktop caps, the IVE is. The ERVI might. So how it works is our rep version of the full desktop caps is a version ahead of what the engineer's desktop has. And I don't think ECAPS has been updated with those new units yet. The ECAPS update is on a slightly different schedule. Greenheck
I
obviously
do
has its own
know. Yeah,
dedicated
the
software team.
ECAPS, whenever the soonest release comes out, that one will have ERVI. So I think that might be live right now in ECAPS.
Oh, okay. These are great questions. This is probably the most
Yeah.
questions we've had. You should feel honored, Jordan.
Got another one here from David. Confirming these units can also have integration with demand control ventilation and duct static control to adjust unit airflow as space fan air demands may change.
Correct,
I
yes.
believe, Yeah, those are on that ERV10 model for the wheel units and the ECV10 and up. I don't actually, did they have the duct on the minis?
So the minis just use a 0 to 10 volt field signal. So, you could provide that, but all of the larger commercial units, we actually have factory sequences and sensors for both duct static and building pressure as well. So definitely something we offer.
And that's a pretty common one. It's like on the ERVI, right? With the EC motors, you're gonna be able to do a duct static pressure sensor, have it come downstream, and then we can have the exhaust track what the supply fan is doing, right? Proportionally controlling, keep your pressure in check.
Correct.
All right, Jackson, I asked Chris this previously, but I'd really appreciate adding the inlet outlet dimensions to the CAPS generated cut sheets.
Okay, point noted.
Yeah. I mean, that seems like a pretty easy one that can, yeah, you might want to jot that one down, Jordan, if it's not already in there. I'm actually surprised it's not. It's probably listed in the IOM, right, the install guide for those units, but it would make sense that you'd want to see that on the cut sheets as well. Do the mini vents have, do the mini vents have an option for integrated supplemental heat? They do not have the integrated control to enable or disable a separate heater. That's not to say you couldn't install a separate duct heater downstream with an airflow sensor that only turns on when the airflow is proven. What Jordan mentioned on some of the other units is we can actually have an enable signal from the base unit and control the temperature. If you're on the smaller side, you're using something like the mini vent, it's really just got to be two separate components, the mini vent and a separate duct heater. At any controls, trying to integrate the two would be by the field.
Yep, to Chris's point, really, there's kind of three options there, right? You either go with like a mini vent here and do it yourself. As far as post heat, you could use a larger commercial unit and control it directly from that ERV or that new IVE that has it integrated from the factory. So I should scoot over a little bit here.
Point at the beautiful units. And you're seeing part of the showroom from there in Schofield, and I see some people on this list that have definitely got to see Jordan present in front of those units in person, and that is a functioning ERV model on I guess the left side, the way I'm looking at on the screen. Oh, yeah, there you go. That is a functioning model, and it's pretty cool to stick your hand in front of the discharge and actually feel the change in temperature when we engage the wheel. So we love taking customers up to the factory. I think I've got four trips in 7 weeks. So I enjoy going. Greenheck does a great job. Is frost on the enthalpy wheel an issue? Does it need a heating coil?
Yeah, so that's a really great question. And it goes back to that HRV versus ERV debate, right? So sensible only versus enthalpy recovery. Another really big advantage of the ERVs in the enthalpy wheels and cores is that they are much more resilient to frost, right? So typically we don't need a heat coil on an enthalpy wheel or enthalpy core. To be honest, I would say probably down to 0 without much question. Depending on the job, it can be even lower than that. So they're very resilient to it. Whereas on the other hand, if it's a sensible only device, typically you need a much larger electric heat coil, and they are much more likely to frost.
I just did a screenshot of an image from the catalog showing kind of the frost control strategies. And actually it's always interesting. It's always a much lower temperature, right? Than we would tend to think about. We think, oh, it's a freezing temperature, we need a frost control. But that's not actually the case. So it's a nice little reference chart that we use when sizing. Great questions.
Yeah. Typically, I see timed exhaust for the frost control method most of the time. I don't know what you're seeing, Chris.
That kind of was always the go-to. I always thought I always called it the cheap insurance. It wasn't that much of an ad to have that kind of safety in there. The modulating wheel in the past, from as I'm dating myself years ago, was always a little more expensive. But that has come way down in cost. And now when we're trying to look at efficiency gains on the economizer side as well, instead of doing a stop wheel for your wheel economizer, we can do a modulating wheel for both your frost control and your economizer mode, because you're only paying for it once. So if you're paying for it for your economizer, it becomes a great frost control strategy. And the same thing the other way. If you're getting it for your frost control, great, you're not having to pay for it again. Now we can use it as your economizer mode. So especially on the new ERVIs and IVEs, going to that modulating wheel for both your frost control and your economizer mode is kind of the way to go. It's kind of a no-brainer in my opinion. I'm stealing your pitch there, Jordan.
No, you're good. And just to add to Chris, we do have some pretty nice factory sequences with those economizer modes as well, right? So we can control off of both the enthalpy or temperature set point. So
yeah,
a lot of technology.
That image that I screenshotted in the chat is both the frost control and the economizer control sequences from the catalog. All right. Anything else?
Pretty straightforward here. Well, thank you, Jordan, for coming here and presenting. We always appreciate that. And this is our last power hour. Chris, you got any closing sentiments you'd like to say?
Thank you all for attending and make our presentations a success. Dorsey has a lot of cool things in the works that we have to, keep our lips sealed about. But Dorsey will be adding a few new products, and Greenheck has a few new products coming out as well. So we're going to do a fall series of the Power Hour. We are looking at September and October, so we're kind of in pre-planning for that to kind of introduce some of the new products and manufacturers that Dorsey's bringing online. If you have any topics you would like to hear about, please let us know. Email your Dorsey representative. We'd love to have a webinar on topic X. Let Blake, myself know. Everybody has my email address. You all get feels like 100 of them for my name. But also with Jordan here, if you would like to have this presentation for your own firm, your own company, whether you're an engineer, a contractor, owner, architect, we can make that happen for any of our topics. Energy recovery, especially in our Pacific Northwest market, extremely popular. As you can tell, Jordan is well versed in our Washington State Energy Code. We bug him a lot about that. So we're happy to give this presentation. We're happy to have Jordan present, and we're also happy to take groups up to the factory. So with that, thank you.
All right, signing off. Thank you, Jordan. Thank you, Chris.
Thank you.
Till next time.
Till next time. Till the fall. Thank you all for joining us, and hopefully we'll see you in a few months.